Hey guys, my name is Sandeep Patel. I'm the founder and CEO of Slotify.ca. In this video, we are going to learn about the insertion sort. This is a sorting algorithm for array data type, right? You can sort an array in ascending or descending order using insertion sort, right? If you remember in your childhood, right, you must have played card games, right? So let's take an example. Let's say that you have a deck of 5 cards, right? You first pick the first card. Um, you have the first card, you can do nothing with the first card, right? When you pick the second card, and at that time you figure, okay, this card is like say smaller than the first one, then uh, try to put that card on the left side of your previous card, right? And then let's say you pick another card. If that card is a bigger, you put it on the right, right? And so on until you sort all the cards in your hand. So this is a similar concept in the insertion sort. Let's take a look. All right, so as I said previously, right, when you pick the first card from the deck, there's nothing to do, right? It's already sorted, right? So that's the reason why we'll start with first iteration, like we will skip the index 0, right? We start with index 1. So let's say you have array 53842, so we will start with the first index, right? So let's say we pick this card. Okay, it's a number 3, right? So we'll look at the cards on the left side. So for example 5, right? So okay, the 5 is greater than 3, so we're gonna insert this card before number 5, right? And then we move on, right? We move on to the next index, right? In this case 8, right? So this 8 card, we're gonna compare it with the 3 first. Okay, so it's greater than 3, so we're gonna skip. Then we go to number 5. Okay, it is greater than number 5, so we're gonna insert after 5, right? And then we're gonna move on to the next index, right? We pick number 4, and then we start from the 0 again. We compare it with 3. It's a greater, so we're gonna go. Um, we're gonna insert in after 3, right? Because number 5 is already greater, right? So that's how we do until all the cards or all the elements in the array are sorted. All right, so let's write some code so we can understand this better, right? Okay, so let's try with this. So as I said before, when you pick the first card, let's say there is a deck of n cards, right? Where n, what is n? So n would be the num array dot length, right? So this is, let's say this is our deck, right? Length of our deck length, right? All right, so now what we do is we pick one card from the deck, right? So for let I equal, we will start with the first element, as I said before, because when you pick the zero card, let's say first card, there's nothing to compare against, right? And in array the index start with 0, so we're gonna skip the 0 index, we start with the 1, right? And then we can say, okay, I less than the deck length, right? And then I plus plus. Okay, so now that we're going through each card, what we want to do is we want to first declare the current card, right? Let's say current card. So what is the current card? It will be number array and I, right? So this is our first card. So let's find the previous card, right? Previous card index. So what would be the previous card index? I minus 1, right? So we're gonna start from 0 until we find this current index, right? So while let's say this previous index card should be greater than equal 0, right? And then whatever the card we get at that previous index, in this case num array, the previous card index, right? That should be greater than our current card, right? If that is the case, what we want to do is we want to swap the card, right? So we would say num array, then previous index card plus 1, right? And we will swap it with the current index, right? Okay, and in this case now we can move on to the next card minus minus. Okay, so let's see this in this code here, right? So let's take an example here, right? Or maybe let's take this example. When we pick this card, right, when it's I minus 1 is here, so this is the previous index, so we are going in this direction, right? And let's say that 8 is greater than 4, so we skip that, then we do j minus minus, we come here, this is also greater than 4, right? So we go minus minus, we compare this is less than 4, so we insert at this position, right? So this is what we're doing here. Okay, so once that is done, and let's say that we didn't find a spot to insert, in that case we insert this current card into the same position, right? Number array, so we would say that previous card index plus 1 equals current card, right? So this is how we do this. Let's run this code and check. All right, so we can see we had this array unsorted, and now we sorted in the ascending order properly. Okay, so what is the time and space complexity of this code? So whenever we calculate time complexity, we're only concerned about the code where it grows with input size, right? So for example, this number array, if there is a code in this function that depends on this input, then we are concerned about that one, right? So we'll start with the first statement. So this one does not depend on the input array, right? So that is 1 unit of time. What do I mean by it doesn't depend on input, right? So for example, no matter how many elements in this array, when deck length would be a single number, right? For example, if there are 1,000,000 elements, the deck length would be the million, right? It's not growing from 0 to million, right? It's the static number. So that's why we take it as 1 unit of time. We start with this for loop. It's running from 1 to deck length, right? So deck length is what? Input size. So now this loop depends on the input size, right? It's growing from 1 until n, where n is the number of array elements. So let's say the number of element is right now is 5, but maybe it's gonna go from 5 to maybe let's say 10,000, right? So in that case, this loop will run 10,000 times, right? So basically we can say this loop runs n times, right? So everything inside this loop will also run n times, right? Like all this code. But there's another loop here as well, right? So this loop also is going from, let's say, the previous element until it becomes 0, right? So it is possible that, let's say, this previous card index I could be the last index in the array, right? So basically this is also going n times. So this statement, like this are static statement, I would say this is like 1 unit of time, 1 unit of time, and also this one is also 1 unit of time, right? So basically this run n time, this also run n times, so n and n square, right? And therefore this statement will run n square time. This will also run n square time, and big O concerned about the bigger term, so we'll pick one of these, right? So let's say this runs n square time, and so out of the whole code, right, the complexity of the bigger complexity comes from this for loop, right? So I would say this is O of n square, right? And what is the space complexity? If space complexity, in space complexity we are looking for there are variable declared in this code, right? So we can see it here, right? But this, it does not depend on the input size, so this is 1 unit of space. So we ignore this for now. And then are there any other variables there? This variables, right? But they're also static, right? They don't grow according to input size, right? No matter how many times this code runs, right, the I variable, the I value would still be same, right? It's not growing from 0 until I. It's I only, right? Okay, so there are no major variable used here, so we can say the biggest space complexity of this code is O of 1, right? Alright, so I hope you like this video. Please stay tuned for my next video on another sorting method. Please subscribe, like my videos. Thank you.